Concept 1. Theory of plate tectonics. Intraplate activity. A small amount of geologic activity, known as intraplate activity, does not take place at plate boundaries but within a plate instead. Mantle plumes are pipes of hot rock that rise through the mantle. The release of pressure causes melting near the surface to form a hotspot. Eruptions at the hotspot create a volcano. Hotspot volcanoes are found in a line, figure 1.16. Can you figure out why? Hint. The youngest volcano sits above the hotspot and volcanoes become older with distance from the hotspot. An animation of the creation of a hotspot chain is seen here, http://earthguide.ucst.edu/. Geologists used some hotspot chains to tell the direction and the speed a plate is moving, figure 1.17. Hotspot magmas rarely penetrate through thick continental crust. One exception is the Yellowstone hotspot, figure 1.18. Figure 1.16. The Hawaiian Islands are a beautiful example of a hotspot chain. Kilauea volcano lies above the Hawaiian hotspot. Mauna Loa volcano is older than Kilauea and is still erupting, but at a lower rate. The islands get progressively older to the northwest because they are further from the hotspot. Loihi, the youngest volcano, is still below the sea surface. Plate tectonics theory. Plate tectonics is the unifying theory of geology. Plate tectonics theory explains why Earth's geography has changed through time and continues to change today. Figure 1.17. The Hawaiian chain continues into the Emperor Seamounts. The bend in the chain was caused by a change in the direction of the Pacific Plate 43 million years ago. Using the age and distance of the bend, geologists can figure out the speed of the Pacific Plate over the hotspot. Figure 1.18. Volcanic activity above the Yellowstone hotspot on the North American plate can be traced from 15 million years ago to its present location. Some places are prone to earthquakes while others are not. Certain regions may have deadly, mild, or no volcanic eruptions. Mountain ranges are located where they are. Plate tectonic motions affect Earth's rock cycle, climate, and the evolution of life. Lesson summary. Plates of lithosphere move because of convection currents in the mantle. One type of motion is produced by seafloor spreading. Plate boundaries can be located by outlining earthquake epicenters. Plates interact at three types of plate boundaries: divergent, convergent, and transform. Most of the Earth's geologic activity takes place at plate boundaries. At a divergent boundary, volcanic activity produces a mid-ocean ridge and small earthquakes. At a convergent boundary with at least one oceanic plate, an ocean trench, a chain of volcanoes develops and many earthquakes occur. At a convergent boundary where both plates are continental, mountain ranges grow and earthquakes are common. At a transform boundary, there is a transform fault and massive earthquakes occur, but there are no volcanoes. Processes acting over long periods of time create Earth's geographic features.